Hello all. Today we are going to a three-phase half-controlled converter with RL load. In the previous video we have seen the converter using an R load, and today we are going to do the same with RL load. Now, as said in the previous class, we are using a delta star transformer. The primary is delta and the secondary is the star connection. T1, T2 and T3 are the thyristors used. And we are having RL load. Now we will see the waveforms and how this circuit is working. Now this is a three-phase waveform, and you can see the three phases R, B and C with 180-degree phase shift. Now in the previous class we have seen that we are taking the alpha from this coinciding point. Alpha is equal to 0 means omega t is equal to 30 degrees. So from this point to this point, phase A is having the maximum value. So we are counting the alpha from this point. Alpha is equal to 0 means omega t is equal to 30 degrees. Alpha is equal to say 10 degrees means 30 plus 10. That will be the omega t, corresponding omega t values. Now so if you are having some alpha, then T1 conducts from 30 plus alpha to 150 plus alpha. If alpha is 0, it is conducting 120-degree conduction angle. So 30 to 150. If you are having a particular value of alpha, it will be conducting from 30 plus alpha to 150 plus alpha. The second thyristor will be conducting from 150 plus alpha to 270 plus alpha. Third thyristor T3 will be conducting from 270 plus alpha to 390 plus alpha. So each SCR is supposed to conduct for 120 degrees. But in the R load, what we have seen is that when omega t is equal to pi, that corresponding thyristor cannot conduct, and the next thyristor will turn on only after alpha from its measuring point. So all those things we have seen in the previous class. Okay. Now in this case, even if voltage at omega t is equal to pi degrees, even if the voltage is 0, current will not be 0. The reason is because this is an RL load, it's an inductive load. So although voltage becomes 0 at omega t is equal to pi, the corresponding current will be having a positive finite value. So the current will not be 0. So the thyristor can conduct beyond this the corresponding pi value. That means the voltage can be negative. The voltage across thyristor can be negative here because the current is still positive. Current may be still positive. So suppose we are taking an alpha here. We are taking alpha point here. So so I will draw the waveforms here. Suppose if you are triggering the circuit at alpha is equal to 45 degrees, for example. So it may be something around here. So the voltage will jump like this and it will move like this at omega t is 0, but the current is still present there. So the voltage will continue to decrease and it will move up to the next triggering at 150 plus 45. Thyristor B will be triggering, then naturally T1 turns off and you will have the voltage waveforms like this. So this will be the voltage waveforms for when we are having from, I'll say alpha is equal to 45 degrees. So you will be having similar waveforms. You can extend like this. So this is the waveform we are getting for an RL load. We can see that we are having some negative portions. The reason is because the current is still positive. Suppose you assume a constant current. Let the current be constant. So this let the output current be constant value I0. So the only question is, during when T1 is conducting, this I0 will flow through T1 when at 150 plus alpha T2 will be triggered, so I0 will be passing through T2, etc. So if you are drawing the waveforms of current, so this will be the output waveform, voltage waveform, output voltage. Now if you are drawing the current IT1, this is IT1 from this interval, from omega t is equal to 30 plus 45, if it is 45, or omega t plus alpha to 120 degrees, it will be flowing through thyristor T1. It will going to this 220 degrees conduction angle. This is flowing through thyristor T1. If you are drawing the waveform for IT2, the current for waveform, the next 120 degree it will be flowing through T2. So this is the current flowing through T2. So this is how you are getting the waveforms. Okay. So here beyond pi also the corresponding thyristor will be conducting. When omega, for the, even if the voltage is negative, the thyristor will be conducting, because the current is finite and is having a value. If the inductance is very large, the I0 can be considered as a constant value, and during with the switching changes, say from T1 to T2, the I0 the flow of I0 will transfer from T1 to T2. So at one time, one thyristor will be turned on, and this is the waveform for a RL load. Now another question is, suppose if you are having a the firing angle greater than 90 degrees, what happens is you will be having more negative voltage. So you can see here also that this portion of current is actually voltage is positive, and this portion of the voltage is negative. Current is always positive. The output current is always positive. So positive current into positive voltage into positive current is positive power, but when the voltage is negative, power is negative. So there is some portion in the circuit, some portion in a cycle where power is transferred from the DC to AC. It is an inverter action. But just imagine that if you are having more negative voltage, negative portion in the voltage waveform compared to positive waveform, then it will be working more as an inverter. I repeat, if you are having more negative portion than the positive portion of the voltage waveform, so then the circuit is experiencing a power transfer from DC side to AC side. So it will be acting more as an inverter. Practically that will happen if you are having a DC voltage source at the secondary side with the reverse polarity. Okay, we will come to that portion later. Now we will write the points that we have discussed. So we have seen that in the explanation that I have given, we have assumed that the inductance is very large and I0 is equal to continuous and constant. Now in the interval from 30 omega t is equal to 30 degrees to 90 degrees alpha. So when alpha between 30 and 90 degrees, for example, you can take alpha is equal to 45 degrees. Then T1 thyristor SR T1 conducts for omega t is equal to 30 plus alpha to 150 plus alpha. We have seen that T2 will be conducting afterwards from omega t is equal to 150 plus alpha to 150 plus 120 degree means it is 270 plus alpha. So each thyristor will be conducting for 120 degrees. T3 will be conducting for omega t is equal to 270 plus alpha to 390 plus alpha. So that means each SCR conducts for 120 degrees. At omega t is equal to pi, what happens? The output voltage is 0. We have seen the waveform, but the current is not 0, is greater than 0. Why? Since it is an RL load. That means T1 continue conduction beyond omega t is equal to pi, unlike in the case of R load. So V0 is equal to VA till that point. Now, when is the next thyroid turned on? When omega t is equal to 150 plus 5, it's 150 plus alpha. 150 plus alpha. So earlier thyroid was conducted from alpha to 30 plus alpha to 150 plus alpha. I had to discuss. Next, in omega t is equal to 150 plus alpha. This one. T2 turned on, and the load current I0 shifts from T1 to T2, and T1 is reverse biased. So this is the case when alpha is between 30 and 90 degrees. Now the question is, what will happen when the alpha is beyond 90 degrees? 90 less than alpha less than 180 degrees. For example, say alpha is equal to some 150 degrees. You can take. So what will happen? The average voltage becomes negative. The average voltage becomes V0 average becomes negative. We can see how it, for let you say alpha is equal to 90 degrees. What will happen? Exactly at the boundary point, alpha is equal to 90 degrees. Say alpha is equal to 90 degrees. So what will happen? Omega t, for example, the T1 will be conducting from 30 plus 90 to 150 plus 90, because next triggering happens only at 150 plus 90, because this alpha is common for all the three phases. Now, so that means from T1 will conduct from 120 to 240 degrees, right? That means the positive portion, 120 to 180 degree portion is the positive portion of the waveform, and 180 to 240 degrees will be the negative portion of the waveform. That means 60 degrees positive waveform and 60 degrees negative waveform. So this is the boundary. If it is beyond 90, what will happen is that it will be more negative voltage. So you can analyze by yourself. So V0 average is negative. That means it converts. So that means converter operates as line commuted inverter, which is only possible practically if the load circuit has a DC voltage source of reverse polarity. So that will be practically possible if you are having a E or E at the secondary, voltage source at the secondary. It can be a battery or a counter EMF, etc. So this is how a RL load behaves for a. This is how the waveforms of a of the half control circuit for RL load. Thank you.